Hello everyone. Today I want to show you how you can use the hierarchical regression and then how that is different from the method stepwise. So if you want to group the independent variable together and you want to know that attached to that variables in different groups, how they build models, and then how these groups make a kind of different variances. So in that case, you can use the hierarchical regression. So in this data, you can see that in fact the labels. Let's see. Here you have the oral communication and the written comprehension, oral expression, and written expression. So these four variables will be used as independent variables, and then how they affect the in fact you can see here the performance, no, overall performance rating. So we consider that those four factors will influence the overall performance rating, for instance, in a sales department. So the one person can imagine that first oral comprehension, oral expression, those two independent variables are crucial for a salesman. And then we can also assume that maybe written comprehension and the written expression can also influence these faculties of the oral expression and oral comprehension to become performant. So for this regression, we can first go to the analyze and then regression and the linear. So here the dependent variable was the performance rating overall, that is in the dependent. And now we can choose the first, which one was the oral comprehension, that was independent variable, and the oral expression also. So we can put them as the method of the enter. This is very important to notice, because if you put that as a stepwise, that means that you command to make the model with which one is the most variances and the second one is the less variances. So we don't use that for this time. We will group them as an enter, so they will enter at the same time. Okay, so we can use that and the statistics and then estimate, and then you can do the model fit, and then collinearity diagnostics part and the partial correlationship. And then we don't choose the hierarchical change because when you enter the when you choose the method enter, they will not show anyway because those two variables they are considered in the same like one block, so one group, so they will not build another models. So I say again, this enter it should be the condition for this analysis today. Okay, so in then you can do okay. So method is enter. So do two variables entered at the same time. And they show the variances and that variances I square. So it's about the 65%. They explain about the performance score. So it's a very high. And then you can see the no-by was significant. And then you can see that the that unstandardized B means that how much variances they give. In fact, the beta that is the corresponds to the in the R square. So in fact, the 53% was explained by the oral comprehension, and then 38% was explained by the oral expression. So or overall, together, they have the 65% of the variances to explain about the performance. So this is about linear regression when you use the enter as a method. Okay. So now let's do another regression as I explained in the beginning, hierarchical. That means that we consider also the written and the written expression and written comprehension can influence to the performance of the salesman. But we don't know how much it will be, so we want to do by step. So analyze and then a regression and a linear. And then now you put them as the first one and then you do the next one and you will enter now is a written comprehension and the written expression. So they will be separate and then examined, and then they will make the two models. So here now with statistics, and you can do the R-squared change. Now they will show these differences. So continue, and then okay. Okay, and now you can see that two variables first enter, and the second two variables enter. So this means that it's cumulative. This doesn't mean in the first model it has only that, and the second model only that. No, first that entered, and then it's added these two variables. So you can consider that when you do the hierarchical regression, that is cumulative. It's not removing the first enter. Okay, and then you can see here R-squared change now, that is here. So it was 65% and they added only 5%. So in fact, we can consider that written abilities that is not very much significant, even though they are significant. So you can see that model 2, even though the variables entered, and then they are still significant. So the first model with only the oral abilities is significant, and the written is also. So four variables, when they entered all, they are significant. And now let's see how much significance they have, like effect size. And you can see here that is beta, yeah. So that is about 35%, and this is 28%, and this was no, in fact that is not still not yet percentage. That is about in fact it's a R value. So we have to scale them. So you will do that, but in fact though you can see it's a kind of a big difference. In the written comprehension is almost the same level like oral expression. Okay, so here we can check again. When you see the together, they have the here is a okay. So R square it is 65% with the first group of the oral abilities, and the written ability is with the written abilities is about 70%. So this means that it's only about 6% was added. Okay. So this we can find from here. Okay, so this was the hierarchical regression. So as you can see that there are only two models were built, even though we put the four variables, because we put with the enter method, and then they will not separate which one is more variances. They will put together and then together again. So only the two steps. Okay, this is about the hierarchical regression. And next time, I will show you how you can conduct also with the stepwise, and that changes the, in fact, the model numbers. Thank you.